A new fuel cell could enable electric aviation. I hope everybody's having a fantastic day. It is time to look at another science article here. This one's sourced from MIT. It is dated May 27th, 2025. Let's read the summary. Engineers developed a fuel cell that could offer more than 3 times as much energy per pound compared to lithium-ion batteries. Powered by a reaction between sodium metal and air, this device could be lightweight enough to enable the electrification of airplanes, trucks, and ships. This particular article was super dense, and it had a lot of it, but it was a super cool read. And honestly, the research that they're doing here and what they're coming up with, it could be revolutionary. I'm not gonna lie. With that being said, this is an article I encourage you to read yourself. Read everything about it. It's super cool. This one I got on ScienceDaily.com. Just look for the title. It should be pretty easy to find. Instead of a battery, the new concept is a kind of fuel cell which is similar to a battery, but it can be quickly refueled rather than recharged. The fuel that they're going to be using for the fuel cell is liquid sodium metal. It's inexpensive, widely available, and the other side of the cell is just air. And it's just going to serve as a source of oxygen atoms, and then in between that it's a solid ceramic material, and that's going to be the electrolyte, allowing the sodium ions to pass freely between them, and then that reacts with the oxygen and produces electricity. This is a pretty good quote that I thought I would include. It says, "We expect people to think that this is a totally crazy idea. If they didn't, I'd be a little disappointed, because if people don't think something is totally crazy at first, it probably isn't going to be that revolutionary." And I honestly think that's a fantastic outlook to have on anything that you do. Now, the threshold that they have for this battery to become commercially successful and realistic is 1,000 watt-hours per kilogram. Most electric vehicles today with the lithium-ion battery max out at about 300 watt-hours per kilogram, so they need a lot more than that. Even if they're able to hit that 1,000 watt-hour benchmark, it's not going to be enough for transcontinental or transatlantic flights, mostly regional and domestic flights. But the fantastic thing about that is that 80% of all flight is domestic or regional, and it accounts for 30% of all emissions from aviation itself. So that would still be a huge step in the right direction. And if this is actually commercially successful, other sectors like rail and marine could follow suit. In tests of this new battery, they were actually able to get it to 1,700 kilowatt hours. This is in a humidity-controlled environment, though, but that does translate to an entire stack in this system having just over 1,000 watt hours. So they're right on the cusp of this. One of the things that they're working on now is trying to upscale this, which they said could be pretty easy to do, and hopefully they have that in the works within the year. So as far as the byproduct of this goes, I'm going to read this part of the article. Researchers envision that to use a system like this in an actual aircraft, fuel packs containing stacks of cells like racks of food trays in a cafeteria would be inserted into the fuel cells. The sodium metal inside these packs gets chemically transformed as it provides the power. A steam of its chemical byproduct is given off, and in the case of aircraft, this would be emitted out of the back, not unlike the exhaust from a jet engine. And the big difference with this is that there is no carbon dioxide with this. The emission would actually consist of sodium oxide, which actually soaks up carbon dioxide from the atmosphere. It would then combine quickly with the moisture in the air to make sodium hydroxide. It would then combine with more carbon dioxide to form sodium carbonate, which would then form into sodium bicarbonate, also known as baking soda. Then, as another benefit, if that final product ends up in the ocean, it could help deacidify the water, which could then help counter effects of greenhouse gases. Another added benefit is that fuel cells are way safer than just normal ion batteries, because one of the other channels of this fuel cell is just air. So if something ruptures, you don't get the big chain reaction. Producing enough of the sodium metal too should be pretty practical, they say. Before leaded gasoline was phased out, it was actually mined at about 200,000 tons a year in the United States. The fuels should also be recyclable and reusable as well. They envisioned that the system in place would be using a refillable cartridge, which would be then filled with liquid sodium metal and sealed. When it's depleted, it would be returned to a refueling station, loaded with fresh sodium, and since it has a melting point of only 98 degrees Celsius, it would be easy enough to melt and recharge the cartridges. The plan is to produce a brick-sized fuel cell that can deliver about 1,000 watt-hours of energy, enough to power a large drone in order to provide the concept for a practical form that could be used for agriculture as an example. The team hopes to have such a demonstration ready within the next year.